British Navy aircrew officer, Paul is a nutritionist, exercise physiologist and neuroscientist who is now also completing a PhD in medical studies. Paul is the founder and former creator of PT Academy, the creator of BioAge software and the director of the Body Brain Performance Institute. His latest venture, Ritualize, has just entered into a partnership with Medibank to improve the health and wellbeing of Australian employees. He's an absolute Philex favourite. We're thrilled to have him. Please make him very, very welcome, Paul Taylor.
Thank you. So guys, I am literally doing a 1-hour presentation in 20 minutes, so I need to make sure that everybody's brain is awake. So can everyone copy me? So that should be your right hand that's out. Who's got their left hand out? Yep, there's always a couple. Now, with your left hand, I want you to point your finger at me, have your thumb alongside it, just like this. Now what I want you to do is engage your brain and switch. And switch back. And back. And back again. And keep going. Fast, fast, fast. That'll wake your brains up. Now, I said I've got an hour's presentation to do in 20 minutes. I've just been told I'm not allowed to swear, so that'll trim about 10 minutes off my presentation. So, but guys, what I want to talk about is hormesis. And I'll go into it in a second, but to explore hormesis, we need to really understand how we function, at what level we actually function as in normal daily function. And we can see we have all of these different organ systems that run our body and organs and underpin it and tissues and all of that. But really, we operate down at this level, at the level of our DNA, at gene expression and metabolic pathways that drive what happens inside the cell and that cell-to-cell communication. And that's really what I'm going to talk about a lot today, is what happens down here and the sort of things that affect it. So we know there are a number of cellular stressors that we all know. Things like pesticide, herbicides, heavy metal, radiation, free radicals, psychological stress we know can affect you at a cellular level, and also heat and cold stress. But I'm going to spend the next 20 minutes kind of poking this stuff a little bit. Here is what we can see is exposure in rats to dioxin, which is a highly toxic chemical. And what we actually see, oh, that's just dropped out. That's useful. Sorry, give me a second. That has just chose to quit, which isn't very useful. So, as I was saying, dioxin is we know it's a highly toxic carcinogenic chemical. But what we see is when animals or rats are exposed to dioxin, when they're exposed to small amounts of dioxin, it actually has some cellular benefits to it. And the rat actually improves its health. And it reduces the amount of tumours. But when it's exposed to high levels, then there's an increase in the amount of tumours. So here we can see phosphate, which is a plant herbicide. And the prevailing thinking is that any exposure to herbicide is going to have a negative impact on the plant. But here we can see that a small exposure to it actually increases growth within the plant. So it has a positive benefit. Here, cadmium, you guys will all be familiar with, is a heavy metal that is highly, highly toxic. But when we look at young and female flies, when they're exposed to cadmium, small doses of it, it actually increases their reproduction facilities. So that small exposure to toxins that at higher doses we know are absolutely lethal is turning out to be beneficial. Here, and you might say, hey, that's just in animals, but here is a study from Russians who were exposed to a nuclear radiation leak. And one, if you look at that, is the relative risk of cancer. And that's in just background people, so people who weren't exposed to it. You can see those who had small doses of exposure actually had much less cancer. And even at higher doses, they still had less cancer than the people who weren't exposed to the radiation at all in any way, shape, or form. And it doesn't just happen in nuclear radiation. We know that cardiologists who perform heart operations and they're exposed to X-ray radiations, those who are exposed to the highest, actually increase their longevity. And it improves their cellular resilience. And it turns out there's actually 233 publications in PubMed looking at cancer incidence and exposure to radiation. And the research has shown that all of this cannot be due to what we call the healthy worker effect, as in when someone goes to work and has a job, they actually become healthier. What we're seeing consistently in the literature is low-level exposure to radiation actually reduces cancer, which is something that we hadn't thought was possible. And this is all about hormesis. That which does not kill us makes us stronger. So hormesis is about sublethal exposure to stressors or toxins that at high levels will kill us, at low levels actually induce stress resistance because of changes in our metabolic pathways down at a cellular level. So we can see here the typical, and even in the light of all of those research studies, radiologists will still tell you there is a no threshold model, that no exposure to radiation is any good. There are other models around there, which is the threshold model, in that a little bit won't do you any harm, but hormesis says a little bit will actually do you some good. And it's only when it becomes high amounts that the harm actually comes from it. So let's look at a number of things that are relevant for our industry. So growth hormone and insulin-like growth factor is something that particularly people who want muscles are very interested in growth hormone and insulin-like growth factor. And we know that muscle mass is regulated by these pathways, by growth hormone and IGF-1. And so what happens is growth hormone is released from the pituitary. It then has effects on the liver, and it releases IGF-1. And IGF-1 then has beneficial effects on our muscle. It also has beneficial effects on fat reduction. We get amino acid transport, increased synthesis. And we're finding that almost all of the positive impacts of growth hormone are due to IGF-1 and the IGF-1 pathway. And also we know when people take branched-chain amino acids, and the recent research is saying leucine is the key one, what that does is that increases mTOR. So mTOR is very important in muscle protein synthesis, and insulin and IGF-1 actually impact on this pathway. So people are taking these branched-chain amino acids, which has a beneficial effect on growth and muscle. So we know that that is absolutely true. We also know that IGF-1 is extremely important in the brain. In the brain, it helps with neurogenesis. It also helps to protect cells, and it creates what we call neuroplasticity. So when you have less IGF-1, the cells tend to become exhausted, and there's less neuronal survival. So IGF-1 is something that's very beneficial for the brain, and I've talked about that many times in recent years about some of the benefits of exercise. However, we now know that IGF-1 and growth hormone has a very dark side. We know that IGF-1 can actually drive cancer, both breast cancer, liver cancer, but also in lung cancer, bowel cancer. A whole heap of cancers have now been recognized to be driven by this IGF pathway. Basically, cancer cells love the IGF pathway. So if you have consistently high levels of growth hormone and IGF-1, you are definitely increasing your risk of cancer because it acts on, reduces apoptosis of cancer cells, and it creates proliferation, and basically the cancer cells feed off it. So that's definitely one of the negatives. We also know that IGF-1 is highly implicated in human aging. And studies of humans have shown that those with the lowest IGF-1 actually live significantly longer than those with high IGF-1. And we've seen this when you can block the receptors in animals, they live longer, all of this sort of stuff. So IGF-1 absolutely fits, and growth hormone absolutely fits the pattern for hormesis. So we know that too little of it, you'll have enhanced longevity and reduced cancer risk, but you'll also have retarded growth. You'll have muscle and bone loss from sarcopenia. You'll have reduced brain function. You'll have reduced libido, and you'll have reduced fertility. So you'll live longer, but life will be pretty crap, right? If we have too much of it, you definitely increase your cancer risk, and there's premature aging. And if you get it just right with hormesis, you'll have neurogenesis, you'll have increased libido, preserved muscle mass, enhanced learning and memory, and slightly delayed aging. And the key thing is it's got to be cycled. You can't have this constant, bodybuilders talk about constantly being in protein balance, and that is actually a negative and can create all of the negatives of IGF-1. So let's now talk about exercise. Exercise, we know, is a very powerful driver of both gene expression and epigenetic mechanisms. And basically, there are different genes that are released from exercise in terms of the time scale, post-exercise, that do lots of really beneficial things. Some of the really cool things released from exercise are heat shock proteins, which are basically cellular aspects of resilience, and they really drive a lot of protection within the cell. We also know that if you take antioxidants when you're doing exercise, you prevent the health-promoting effects of exercise. Because exercise is basically beneficial because it's a metabolic stress. It creates free radicals in the cell, and the cell responds by upregulating PGC1 alpha, PPAR gamma, superoxide dismutase, and glutathione peroxidase, which are all very important in cellular defense mechanisms. And you get what's called mitohormesis, or improved or decreased disease risk at a cellular level. And exercise, we know, is very largely driven by this pathway, PGC1 alpha, that drives the expression of a whole heap of genes and different pathways that end up in reduced inflammation. And when you don't exercise and overweight, you get increased inflammation. So this pathway is really why exercise is very, very beneficial. Now, on the flip side, you guys know exercise, and particularly high intensity or high volume, should be periodized. And I'm speaking to the converted when I talk about overtraining syndrome. And if you're not periodizing, then you can get overtraining syndrome. So in terms of exercise, too little can create metabolic dysfunction, reduce libido, increase risk of depression, and increase risk of heaps of diseases and reduce lifespan. Whereas too much, and you get increased morbidity and mortality, you get overtraining syndrome with all of these different things, decreased physical performance, changes in mood, insomnia, loss of body weight, loss of motivation, all of these different things that happen with overtraining syndrome. And we've actually seen recently that people who do the highest volume of exercise, i.e., this is in terms of cardiovascular exercise, people who run marathons for years and decades and triathlons, actually weaken their heart and have no improved longevity versus those who do no exercise. So exercise certainly follows this dose response. So if you get it just right, you get mitohormesis, you get enhanced brain function, you get improved longevity, improved mood, libido, energy, and protection against a whole host of chronic diseases. Now, calories. We all know what excessive calories does, how it drives obesity, and also all of the obesity-related illnesses. So, and again, I'm preaching to the converted here. And we think that if you don't eat food, you're going to die. But it turns out that moderate energy restriction, caloric restriction, or intermittent fasting is actually very, very beneficial. And every species that's been studied, it extends lifespan very significantly, even in primates and now in humans. And it is the same pathways, it's different serotins that are impacted upon it, but basically it's the same pathways in all these different species. And we're finding now that calorie restriction, if you reduce your calories from between 10 to 40%, you get reduced cancer risk. Or if you do intermittent fasting, you get reduced cancer risk because it upregulates pathways involved in DNA repair and cancer prevention. So here is some of the pathways that are involved in this. Again, I'm not going to go into it because it's a little bit geeky, but you can see that they all block cancer, whereas this pathway, the mTOR, which is involved in muscle mass, that actually drives cancer. So by blocking that pathway, it can also reduce cancer risk. So we can see that exercise very much fits the whole thing of hormesis. Now let me talk about fruit and vegetables. I have used to say for years as a nutritionist, fruit and vegetables are good for you because of the antioxidants in them. We now know that's probably not true. The level of antioxidants in fruit and vegetables is not enough to have a physiological effect on humans. What we now think is that fruit and vegetables are good for you because they have small doses of poison. And those small doses of poison have very positive impacts on your cells. For instance, sulforaphane in broccoli, allicin in garlic and onions, resveratrol in red wine, all will persuade an insect not to eat it because they are toxins, but in us, because we're much bigger, just creates a mild metabolic stress similar to exercise, which creates upregulation in protective genes. And here we can see some of the pathways that are involved. So if you look at here, there's capsicum from capsicums and chilies, and allicin from garlic and onions impacts on this pathway, resveratrol in the SIRT pathway, sulforaphane in broccoli and curcumin act in here. And we actually know where these things act in the pathways in our nerve cells in our brain to actually protect our brain cells against damage. So it is actually the small doses of poison in fruit and vegetables that drives a lot of their beneficial effect, and it's down to hormesis. So here we can see a number of known hormetic dietary polyphenols. There are other ones here, but these are generally the main ones. So we also know phytates. Any paleo guys in here? So paleo guys will tell you, do not eat legumes, do not eat grains because they've got phytates, and phytates are anti-nutrients, and that is true. in some circumstances. So here, let's just have a look at the sources of phytates. You get some in cereals and pulses, but you also get a lot in animal products, so I don't know what the paleo guys have to say about that. But what the research shows is that if you have a diet that is low in basically polyphenol, not just polyphenols, but metals and other compounds, beneficial metals, that is. So if you have a low nutrient density diet, then these phytates are very, very bad for you. But that tends to happen in developed countries. When you eat a good diet, it turns out that these phytates are actually good, and they protect against cancer. And what we have seen is that not only do they protect against cancer, but that they're anti-inflammatory, they drive the immune system, they have anti-angiogenesis, they have all sorts of benefits. And what we found out just a couple of years ago is because we have a bacteria in our gut that digests these phytates. And when it digests these phytates, it produces beneficial nutrients. So something that a lot of people view as an anti-nutrient, when it interacts with our gut bacteria, actually becomes a very beneficial nutrient, or there are byproducts of it that are very beneficial in our metabolism. So ways that you can control it, you should be soaking, sprouting, fermenting grains and legumes and soaking nuts. That reduces a lot of the phytate content. You should eat vitamin C-rich foods with the ones that are high in phytates. Use vinegar in salad dressing because that reduces the absorption. And if that isn't enough, some people who are very prone to it can use phytase supplements. They can mineral fortify foods or supplements. And last one is don't be a vegetarian because that increases your risk. So let me now move on to heat and cold stress, and this is my kind of new favourite topic. So it turns out that when you take depressed people and you expose them to cold therapy, i.e. being submerged in very cold water or cryotherapy, actually it cures their depression or reduces their depressive symptoms. And you can see it is very strongly linked to the decrease in core body temperature. Now, there are lots of other benefits that come from it, but it is this decrease in core body temperature that's pretty key. So this is my little guy, Oscar. He doesn't normally have those. He's just back from Bali. But this is him in a freezing cold shower. So now in my house, everybody has freezing cold showers in the morning. That's Oscar in a freezing cold shower. That's Oscar 30 seconds in. Doing his breathing, being focused. And that was about, I think, probably a week ago. Yesterday, me and Oscar were in a 16-degree swimming pool, which is very cold, for 7 minutes. Because it turns out there are a heap of benefits from cold water immersion. Now, the sports world, we know cold water immersion has been used for years. It's used to reduce inflammation, but it turns out it's got a whole heap of other benefits. And the benefit actually comes if you look at this dashed blue line, and these are different forms of exposure and whether the muscle is reduced in temperature and stuff like that. But it is the reduction in core body temperature that persists for a couple of hours afterwards that actually drives a lot of the process. And it's through something called the RMB pathway. So that is a gene that actually controls the expression of hundreds of other genes that are very beneficial. And here you can see there's different types of partial ice packs, those sorts of things, cryotherapy. That full body head out immersion, so full body up to your neck at around 14 degrees for 14 a minute is what really drives a lot of the benefits. Alternative you can do is 4.5 degree water for 20 seconds and do repeated bouts of those, but that is pretty hardcore. So it turns out that heat stress from a sauna has a whole heap of benefits as well, which I'm going to talk about in a second. And heat stress drives heat shock proteins. So does cold stress, by the way. It drives both cold shock and heat shock proteins, which impact at a cellular level. If you do a workout and then get in the sauna for half an hour, you increase growth hormone by about 200%, right? So it's a very natural way to increase growth hormone. And there are lots of benefits from those increased proteins. So basically, cold exposure and heat exposure, too little of it, you become weak, particularly in the head. Too much of it and you'll probably die. But if you get it just right, here's what happens. With cold exposure, you get heat shock and cold shock proteins. You get increases in noradrenaline, the stress neurotransmitter in the brain, which actually it drives stress resistance, reduces inflammation, improves mood. You get synaptogenesis, new synapses in the brain. You get pain reduction. It's been used to treat arthritis. You get weight loss because your fat turns from white fat into brown fat, which is more metabolically active, just like muscle. And you get improved immune function. It's now being used to treat a lot of autoimmune conditions with great success. Heat stress increases heat shock proteins, growth hormone spikes, improvements in physical performance, recovery, mood, insulin sensitivity, neurogenesis, learning and memory, and longevity. People in Norway who use a sauna 4 times a week have a 40% reduction in all-cause mortality, which is unbelievable. There's not much out there that's like that. And one more thing just before I do a summary, preconditioning. So when I was in the military, we did basic military training, and I also did combat survival and resistance to interrogation training, which was 10 days, pretty hardcore. That uses the HTFU pathway, which in the military stands for harden the fuck up. Right? And that creates what we call preconditioning, which actually drives resistance to stress and increases resilience. So we know the pathways by which this happens, things like neuropeptide Y, but also changes in psychology. The other form of preconditioning is when people go to have an operation where there'll be reduced blood flow to the heart. If they use preconditioning, so basically they block off blood flow for a short period of time and do that repeatedly 4 or 5 times before the operation, the heart actually becomes more resilient and there's less damage from that heart not getting the blood flow. So that's another form of preconditioning that is a hormetic response. So let me summarize, in the last minute. There are lots of different pathways involved in hormesis. There's lots of different exposures out there. That last count, there were over 6,000 things that drive hormetic pathways. And it is driving those pathways at a cellular level that drives stress resistance and gives us improved disease risk, increased resilience, improved mood, all of those sorts of things. And exercise really is a key one. It is only beneficial because it is a stress. That is the only reason that exercise has all of the benefits. So let me talk about a day in the life of hormesis. So this is yesterday. I got up at 05:30 and took my Ridgeback for a run, activated my PGC1 alpha pathway to drive hormesis. At 0600 I got my Mankini on and went for some cold water exposure, activating the RBM3 cold shock pathway. Breakfast, I had lots of blueberries in there. I had some phytates in my oats that had been soaked overnight, activating the NRF2 pathway. And then all day long, I spent creating today's talk at the last minute, as I tend to do, with my head in research papers, activating the HTFU, which we won't say again, but also the cortisol pathway. At several times during the day, I had cups of tea and green and black dark chocolate with catechin and that other thing in green tea, activating the NRF2 pathway. And then 6 o'clock, I did some zoo, which anybody who's done zoo knows it activates the HTFU pathway as well as the PGC1 alpha pathway. And then I had my dinner, which had lots of different hormetic polyphenols, again activating the NRF2 pathway. And then I finished off with a bit of preconditioning for this weekend. Thank you.
Thanks, Paul. That was great. Now, we are going to throw out the opportunity to you guys to ask any questions. Paul, I've just got a question. You mentioned that too little IGF-1. Now, I'm just asking for a friend.
Sure.
Too little IGF-1 can result in retarded growth.
Yeah.
Is it possible that that could have happened in the womb?
No comment, Your Honour.
Okay. All right, so guys, if anyone has any questions for Paul, I'm sure there's many. Kat and I are going to just wander around. There's one in the centre.
Paul, John Collins. You mentioned that fruit and veggies... Thank you very much. Yeah, I think my voice is louder than this. I don't know if that's working.
It's probably for the camera.
Oh, it's working. Okay. You mentioned that your research showing that fruit and veggies are beneficial because of the toxins in them. Yeah. I assume you're talking about natural toxins.
Yes.
How do you feel about pesticides on fruit and veggies, i.e. should we be washing our strawberries?
Absolutely. And 2 years ago, I'd have said pesticides, and I used to eat organic. So 2 things on that. I found out about a year ago, organic doesn't mean there's no pesticides in it. It just means if they use pesticides, they're organic pesticides, right? I'll give you an example of an organic pesticide, Agent Orange. So a lot of the non-organic pesticides have been used to be fit for human consumption at small doses, right? And the previous thinking was there's the zero threshold model, or they had a threshold model. So a little bit doesn't do you any harm, and then more will start to do you harm, right? But with hormesis, and we know from some of those toxins, with hormesis, actually a little bit will probably do you some good. But it's how much for what individual, and that's the key thing. You can't say that there's just a level that's going to be hermetic for every single individual, because it depends on your pathways and other things that are going into your body and other foods and those sorts of things. So now, actually, I don't worry about it. I don't consume a lot of processed foods, so I don't worry about the toxins there. Fruit and vegetables, I'll give them a wash, but I'm not overly concerned anymore about pesticides and herbicides that are not organic, if that makes sense. But it's a great question. Yep, question here.
Paul, just a question. If fruit and vegetables were in short supply, as in none,
yeah,
frozen or canned as an option?
Frozen every day of the week. Okay. And I've just been doing some stuff with Medibank, and Ollie Bridge here is head of corporate health up in Weipa, Far North Queensland, where they struggle to get fresh fruit and veg. Frozen is awesome. Just don't get frozen berries from China. But these days, frozen is generally, if it's snap frozen, it locks in other nutrients in. Now, a lot of the vegetables you buy in a supermarket, Choice did an expose last year, an average apple was 8 months old. As soon as you pick that fruit or vegetable, the nutrients are starting to decay. So when you snap freeze it, you actually lock a lot of the nutrients in. So in many cases, especially in a supermarket, the snap frozen is actually more nutritious than the fresh, if you like, from supermarkets.
From Norfolk Island, we've had none for 2.5 months.
Wow.
So we've had to really think outside the square.
Yeah, frozen and grow your own.
Yeah, great.
One down there.
Paul, you were talking about phytates, and then you mentioned the bacteria in your gut that will help metabolize it.
Yeah.
So how much does your gut bacteria have to do with metabolizing those phytates? And if you don't have it, then what's your risk like?
Yeah, so that is a great question. So the phytates, we know that at higher levels in the human gut, they're actually anti-cancer, and that's when they're broken down and they create all of those. But at low levels, they can be carcinogenic. So that's one thing to be aware of. The other thing is that we do need those bacteria. So whether or not you have the bacteria, we don't really know, right? So that's one of the key things. But one of these things that if you're not eating them, I'm very wary of not eating natural foods. We know that, for instance, people who go gluten-free can actually then develop an intolerance to gluten where there was none beforehand, right? So that muddies the water in all of this stuff. So what we need to do is really delve properly into the research rather than looking at it superficially going, that has anti-nutrient properties, therefore I'm not going to eat it, right? Does that make sense? Another question here?
Thank you. So my question is related to the whole body cryo.
Yep.
What is the frequency?
So the frequency, they haven't done a lot of studies. There are different studies showing that there's benefits when it's done every day, and there's a few other different studies. And I was very interested in the whole body cryo, and I've done a couple of sessions. Anybody been in one? So you stand in this chamber, and within 10 seconds, it's minus 160 degrees, right? Now, it turns out the benefit of any cold therapy, whether it's cryo or cold water, comes from lowering core body temperature. And actually, submersion in cold water is shown to be more effective than whole body cryotherapy. So we don't know the dose response. Again, it would be very individual and depending on what it is. Now, one other thing on that, if you want muscle mass improvements, do not do cold therapy within an hour. It's shown to be beneficial for people going out running and recovery, reducing inflammation. But if you want gains in muscle, if you get into that cold within an hour, it shuts down the pro-inflammatory processes, and they're actually needed to drive that muscle turnover. So wait for an hour, then do your cold therapy. That'll accelerate your recovery, and you'll still get your muscle gains. But to answer your question, there hasn't been enough research on the optimal dose response. And the hormesis would say that you need to do it every now and then, otherwise you become adapted to it. But you will slowly become adapted to it, and then you need to increase the threshold slowly, right? That whole idea of progressive overload.
And then what's the duration of the shower that you put your children in?
The kids start off 30 seconds. I'll go into it tomorrow. Start off with 30 seconds, then do a minute. After about a minute, what happens is your blood flow is reduced, norepinephrine is released, your blood flow is reduced, pain receptors get dulled, and then you find it more tolerable. I find after 2-3 minutes, particularly in the pool, you can stay there for quite significantly longer. But whole body submersion is much better. If you live somewhere hot, get a fridge freezer, you know those fridge freezers? Fill it full of water, bingo.
Thanks. We've got time for one more question. Anyone else? Over here.
How's it going? With your ideas on like the threshold of overtraining, how do you gauge that? And for marathon runners, how like when you say that they could have even a greater heart risk, like what are all your boundaries for overtraining?
So a couple of things on that. So there's two forms of overtraining: parasympathetic and sympathetic dominance. And endurance athletes get one, and strength and power athletes get another. Again, the boundaries are very individualized. Some of the research, there's more research around cardio because it's been done for longer for more people. The Harvard alumni study showed that the optimal distance was about 36 Ks a week, right, of exercise being beneficial. After that, it started to drop off. So they didn't elucidate when it started to become bad, but it is the chronic long-term stuff. And there's other research showing after a marathon, there's a lot of inflammation in the heart, and long-term marathoners start to have problems with the right ventricle. And basically, you train your heart for one of two things. You train it for endurance, which is what cardio guys do, and their heart just works like that, but it becomes smaller and weaker, or you train it for capacity, which is what strength training and high-intensity stuff does. So for me, the simple analogy is look at an elite endurance runner and look at a 100-meter sprinter, and what would you want your heart to be more like? Does that make sense? But in terms of the threshold, there's lots of individual mechanisms that go in there. What's your diet like? What's your recovery? What else do you do? What other hormetic stressors do you expose yourself to? All of those things go in, so we could not give you an answer. But it is certainly when you get up to those 40, 50 Ks a week, that's starting to accumulate damage. And that's when the benefits start to become outweighed by the pro-inflammatory damage. Does that make sense? Thanks, guys.